Friday, we did the domain for these 6 problems, but we did not do the range. Remember, the domain, oh, we didn't make it to any of them? Okay, so let's start with domain. It's the worksheet from Friday. Domain is referring to the x values. The x-axis is the horizontal axis, which runs from left to right. So, if I were on that graph, which I'll highlight yellow so you can see what I'm talking about. And I'm going to go ahead and draw in the arrows. They're there. You can just barely see them. So say that I'm walking on this graph, the yellow part, and I want to go left. How far can I go left? What does this arrow mean? It keeps going. So as I go up, isn't it also slightly going left as well? Think about it. Like right here, it's this close to the y-axis. But then it goes up, isn't it a little further away from the y-axis? And as it goes up further, doesn't it get further from the y? So as it's moving up, isn't it also moving left? So doesn't that mean I can walk left forever? Which is represented with a negative infinity. Okay, well let's say that I've decided I want to go down as far as I can on this graph. So I'm walking. I'm trying to go as low as I can. How low can I go? Forever. However, isn't that as it's going down, isn't it also going right? So I can go right forever. So the domain is all real numbers, negative infinity to positive infinity. Okay, now let's talk about the domain of the next one. Okay, anytime you see a graph and there's no arrows drawn in, but there are also no points, you need to assume that there's arrows. It continues forever. Okay, always assume that there are arrows unless they make it obvious that it's not. Okay? So, domain is only about the x-axis, so left to right. If I'm walking on this line, how far can I walk left? Forever left, and forever left is negative infinity. How far can I walk to the right? Forever, and right forever is positive infinity. Okay, now let's look at this next one. Okay, first I'm going to highlight the function. Okay, and then notice that you have endpoints. One endpoint is at -5, -6, and the other endpoint is at 5, 6. That's a typo. That should be a positive sign. Okay, so say that I'm walking on it, and I want to walk as far as I can to the left, because domain is the x-axis, which is left to right. How far can I walk to the left? Okay, but for the domain, don't I only care about the x value in that point? So the furthest left I can walk is -5. Now, if I want to walk to the right side of that graph, when will I have to stop? When I get to that point, which is where on the x? +5, right? Isn't this point at +5 on the x-axis? Now, aren't both of those points closed? So you put brackets. Because you could walk all the way to that point, which is sitting at -5, and you could walk all the way to that point, which is sitting at +5. Okay, now let's look at number 4. Okay, domain is x-axis, which is left to right. So if I'm on this line and I walk to the left side, that would be going this way. How far can I walk? -4, because I only care about the x value. So -4. But can I actually walk all the way to the -4? What would happen? There's an open circle, so couldn't you kind of consider it like, oh, I'd fall in if I tried to go all the way to the -4? Because it's open, so you show that with a parenthesis, it's not included. Okay, and then to the right, I could walk all the way to this point, which is at 6, but when you fall in right there at 6, so it's not included. It's a parenthesis as well. Okay, now domain for number 5. You tell me, how far could I walk to the left? Is it included? Yes. It's a closed circle. There's a point there. And how far can I walk to the right? 4. That point is the furthest right you can go, and it has an x value of 4. And it's also included. Okay, and then number 6. Correct. If I followed this curve as far as I could to the left, it's at -5, but it's open circle, so not included. And if I followed it to its right side, I could go all the way to 7, but it's not included because it's an open circle. Okay, so that's domain. When you're finding the domain, you're just figuring out how far the graph goes to the left and how far it goes to the right on the x-axis. Does that make sense? Now let's talk about range. Okay, if domain deals with the x values, then range deals with the y values. With domain, we went left and then right, which is basically from the negative side to the positive side, correct? So with range, we'll go up and down, but if we always go from negative to positive, doesn't that mean we go down first and then up? So if you're on this function, and I'm walking and I'm trying to go down, how far can I go down? Forever. That arrow, doesn't that mean it continues going down forever? So it goes down forever, and then how far could I go up if I'm on this function? Up forever, because there's an arrow over there that will continue going up. So for this function, doesn't it go up and left forever and down and right forever? So that's why both of the domain and range are all real numbers. Same thing for number 2. As you're going left over here, aren't you also going down? And as you're going right, aren't you also going up? So the range is also negative to positive infinity. All real numbers. Okay, now for the remainder of these, they don't have arrows, so they're not going to be like that. Let's talk about the range of this function. The lowest point you'll ever have on this function is at -6, right? And what's the highest point? +6. And they're both included because both of them have a point at those locations. Okay, so what about the range for number 4? What's the lowest point that line ever has? Isn't this the lowest point? And what's its y value? -2, but it's not included because it's an open circle. What's the highest point this graph has? 7 on the y-axis, and it's not included. Okay, so what would the range be for number 5? Right, -3 to 5, and then included or not? Both are included. The open circles and the closed circles. You've got to go home tonight and watch that video again. If you already watched it, watch it again. Did you watch it? It'll make sense once you watch it. Yeah. Number 6. For the range, we deal with y values, and we always start with the lowest to the highest. Well, isn't this technically the lowest the graph gets? And isn't that at -6? And where's the highest the graph gets? Ended up here at 8. So really this point doesn't even matter. It's just kind of there as a distractor. The lowest is down here at -6, and the highest is up here at 8. Well, at 8, it's an open circle, so it's not included, so you put a parenthesis. At -6, if you were walking on this, couldn't you walk all the way down until you were level with -6? So it is included. There could be a point there. Okay, now, if you were not here Friday, you need to go home tonight and watch this video and finish the rest of the worksheet. If you were here on Friday, you need to make sure your name is on it and pass it forward and somebody take it up. Everybody else be turning to page 20. We're going to skip number 1 because it's a little bit different, and we'll come back to it. Let's start with number 2. Let's go ahead and take care of the easy part. Is this a function? Why not? Right. If we drew a vertical line anywhere through this, it would hit it in 2 different places, right? So it's not a function. Now let's talk about the domain. The domain is always about the x values. So if you were running around this pentagon, where is the furthest left you could get to? Wouldn't it be right there? And that's an x value of -3. And couldn't you walk all the way until you were on the -3 line? So it's included. What's the furthest to the right you could get on it? positive 3, and it's included. Now remember, on Friday we learned how to also write this as an inequality. So you would write x, because we're dealing with domain, negative 3 and positive 3, and then both of them are included, so both of them get an equal to sign. So your points are less than or equal to 3, but greater than or equal to negative 3. Isn't every single other point on that graph somewhere in between those numbers on the x-axis? Okay, so now let's talk about range. If you were running around this pentagon, what's the lowest you could get? Negative 4. And that's included, because you could actually walk all the way down to negative 4. And what's the highest you could get? 3. And it's also included. Now, what's different about range when you're writing it as an inequality is you put a y in the middle for range. And then you put negative 4, positive 3. All of your values are lower than or equal to 3, but they're higher than or equal to negative 4. If you plotted a point anywhere on that pentagon, wouldn't all the points have y values lower than 3 but higher than negative 4? That's what that means. Okay, number 3. Is it a function? Yes, it would definitely pass the vertical line test. Now let's talk about domain. If you're somewhere on this function and you're trying to get as far as you can to the left, how far left can you get? Negative 4. But think about it. If you walked all the way up to negative 4, wouldn't you fall through the hole? So negative 4 is not included. What's the furthest right you could get? Forever to the right, so positive infinity. So the way you would write that with inequalities is x and then negative 4 and positive infinity. Neither one are included, so neither one get an equal to bar. This says all of your points are less than infinity, but greater than negative 4. And think about it. If you plotted a point anywhere on that, wouldn't that be somewhere greater than negative 4 and then somewhere less than positive infinity? Okay, now let's talk about range. What's the lowest you can get on it? 1. That's the lowest, and that's a y value of 1, and it's included. What's the highest you can get? What does this arrow mean? Right, you can go up forever. So that would be y for range, and then 1 to infinity, and then 1 is actually included. So over here you put an equal to bar. Okay, all your solutions are either going to be at 1 or somewhere higher. Number 4. Okay, this time we have a graph of a circle. Is it a function? No, it would definitely fail the vertical line test. Now for the domain, if you're like traveling around that circle, isn't this the furthest left you could get? Which is an x value of, is it included or not? Yes. I mean, think about it. If you're walking on that circle, couldn't you walk all the way to a point at negative 2? And then what's the furthest right you could get? Positive 2, and it's included. So as an inequality, you put x for domain, and then negative 2 to positive 2. They're both included, so both of them get equal to bars. On the test, you're going to have to know how to write both forms, because like on one question, it'll say, what's the domain, and all 4 of the choices look like that. And then on the next question, it'll ask, what's the domain, it'll be a different graph, and all the choices look like that. So you have to know both ways to write it. Okay, now let's talk about range. What's the lowest you can get on that circle? 0. And what's the highest? 4. So remember, when you're writing as inequalities, you have to put y in the middle because we're talking about range. And then it goes from 0 to 4, and both are included, so both of them get the equal to bar. Okay, number 5, is it a function? Yes, it would pass the vertical line test. What's the domain? Negative infinity to positive infinity, correct? Because remember, when you're doing domain, you're going left to right. Can't you go left forever, which is negative infinity, and you can go right forever, which is positive infinity. So as an inequality, you would write it like this. X in the middle for domain, negative infinity to positive infinity, but those are never included, so you don't put the equal to bars. What about range? Right, same thing. Can't you go down forever and up forever? What was the what for? they're both negative infinity to positive infinity because as you're going left, you're also going down, and as you're going right, you're also going up. So you're going down and left forever, which is where the negative infinities come in. You're going up and right forever, which is where the positive infinities come in. Now, another way to write this, anytime you have negative to positive infinities, remember this little symbol I taught you Friday, the double back R, is for all real numbers. Just think about it. Won't that line cover every single number that exists because it goes forever both ways? R. Okay, I want you to take a second and try 6 and 7 by yourself. Is it a function? Yeah. Yes, it would definitely pass the vertical line test. What's the domain? Correct. All real numbers. You can go left forever and you can go right forever. What about the range? No, you can't go down forever. Isn't this the lowest? And that -5 needs a bracket, right? And then how high can you go? Infinity. So when you write those, you're talking too much. When you write those inequalities, this would be x for domain, and then it goes from negative to positive infinity. Neither one of them are included. And then for the range, the -5 is included, so it gets an equal to bar, but the infinity is not. All right, number 7. Is it a function? No. No, it would not pass the vertical line test. What's the domain? 0 to infinity. Shh. The furthest left you can go is here, which is 0 on the x-axis included. And then you can go, no matter which way you can go right forever. What about the range? Negative infinity to positive infinity. Let's talk about why. If I leave and go this way, can I continue going down forever? As it goes right, won't it go down forever? Or if I leave and go this way, doesn't it go up forever as it goes right? So that's negative to positive infinity. So x, that 0 was included, infinity's not. And then for these, they're both infinities, so neither of them are included. Is this one a function? No. Look, if I drew a vertical line right here, it would hit it twice. Not a function. Can we just continue? Look, I'm going to draw a vertical line. If I draw a vertical line on this part, it hits it once and then hits it again. It still fails the vertical line test. They're still a cheater. This point is -1, 1, and this point is -1, 3. He's a cheater. He went out with 2 different girls. Okay, so this is not a function. Domain. How far left can you go? Negative infinity though, because it's left. How far right can you go? Infinity. Stop talking. Okay, so the domain goes from negative to positive infinity. Okay, now the range is different, so pay attention. Why don't you let me write it and then I'll give you time to copy it. If you're on this graph, what's the lowest you can go? Wouldn't it be this line, which is at 1? What's the highest you can go? 3. However, pay attention, this is where it's different. You cannot simply write brackets, because what that means is that your y values go from 1 to 3. Well, is there anything at 2? No. So to show that there's only something at 1 and only something at 3, you do braces. The ones that look like this, a hump, and then a V, and then a hump. Okay, because that lets the person know that you only have y values at 1 and 3 and not 1 through 3. Does that make sense? Okay, number 9. Is it a function? Yes, it would pass the vertical line test. Okay, pay attention, and then you'll have time to write it. So just watch first. Right now, the furthest left you could go is where? You could go left forever, correct? So negative infinity. However, you cannot simply write 2 right here. Because if I just say 2 because that's the furthest right, then I'm telling you that you can go all the way from negative infinity to 2. You can't. There's a hole right here. So this is kind of like one of those OR inequalities where we have to split it into two things. It goes from negative infinity to negative 3, and then after that it goes from negative 3 to 2. You have to show that there was a gap at negative 3. But all of it gets parentheses because all of it is either infinities or there's holes. So and then you put U in the middle. So does that make sense why we had to break it into two different things to show that you have a piece right here, union, which is my symbol. Union, watch Friday's video. Okay, now let's talk about range. What's the lowest you can go? I am tired. The lowest you can go is right here, correct? Which is a y value of negative 2. Now, I know it's confusing because there's an open circle there, but aren't there also places that aren't open? So it's still included. There are solutions at negative 2. How high can you go on this graph? Infinity. If you travel to the left side, you can go up forever. Okay, now let's go up and do number 1. No, because you're going up forever. Okay, number 1. Is this a function? No. About domain. What's the furthest to the left this graph is? Isn't that the furthest left point? That's a negative 3. What's the furthest right? Okay, however, is there data or information in between all those points? No, guys, there's nothing right there. There's no line connecting those. So you have to write each x value. So now we would do the next left point, which is at negative 2. Then we would do the next left point, which is 2 of them, and they share an x value of 1. And then the furthest left point is at 4. This is where you use braces to show that your domain is only at those 4 locations, not in between them. It's not from negative 3 through 4, it's only at negative 3, negative 2, 1, and 4. Because there's no lines connecting. So for the range, you would do it the same way. What's the lowest point on the y-axis? And then the next lowest? And then the next lowest? That's 0. That point is 0 on the y. And then the next one? And then the last one? 5. Okay, that's how you would do those. Your classwork, which will become homework if you don't finish it, is page 21. So you can go ahead and write it on your pink sheet. Today's day is 1/17.